Hello, Matthews, Gatos here. Welcome to 5.1 Part 2. In Part 1, we dealt with radicals that had numeric radicands, square root of numbers. In Part 2, we're going to deal with variable radicands. So we're going to have x under the root. But before we do that, I want to review what we did last time. So I would recommend that you pause this video, do the question on your own, and then come back to see how you did, since it is a review question. So it says a square has an area of 48 centimeters squared. What is the exact perimeter? So first things first, exact means no decimals. So I want roots and fractions, no decimals. I know that the area of the square is 48 centimeters squared, and squares have equal length and width. I also know the area of a rectangular square is length times width, so x times x in this case equals to 48. So x squared equals 48. So in chapter 4, we learned about the square root principle. So to solve this quadratic equation, x squared equals 48, I simply take the square root of both sides, remembering when I take the square root, it's plus or minus. Now, x equals 2 plus or minus root 48 is the solution to the quadratic, but not the solution to the question. I'm trying to find side length so I can find perimeter, and I know side length has to be positive. So it's going to be the principal root only. So to be able to do this, I need to now simplify the square root of 48. So looking to simplify the square root of 48, I'm going to break it down into its perfect and non-perfect factors. So to do that, I'm going to look at my perfect squares and find the highest perfect square that goes into 48, which is 16. So I know that this breaks down into square root of 16 multiplied by 3. Square root of 16 is 4. So I know that x, which is my side length, equals 4 root 3. So to figure out my perimeter, I can add all the sides together, or since they're all the same, just multiply by 4. 4 times 4 is 16, so the perimeter is 16 root 3. Okay, in this question here, this is a great numeric response question, the kind of question you could see on a check-in. So again, I would recommend pausing the video, trying the question, and then coming back. So we have an expression 4 root 63 minus 2 root 28, and we want to simplify it into the form a root b. So let's first of all start by simplifying each one. So 4 root 63, I start with the 4 on the outside. And now I'm going to go to my perfect square factors, and the highest perfect square that goes into 63 is in fact 9. So I know that this simplifies to be 9 times 7. So 4 times the square root of 9, which is 3, times the root of 7 means this whole thing simplifies to be 12 root 7. Now I want to do the same thing over here. So 2 root 28. To simplify that, again, notice that the 2 is on the outside. I look for the highest perfect square factor. So it's going to be 4 and 7 left over. So 2 times the square root of 4, which is 2, times root 7. So this will be 4 root 7. And then we want to subtract those values. So I'm going to take each of those values and subtract them. So I have 12 root 7, take away 4 root 7. Well, they're both root 7s, so I know that my answer is going to be a root 7, and it's going to be 12 take away 4, which is 8 root 7. So that would be my final answer, which of course I can check in my graphing calculator. So there you see I have my original question and my answer, so I know I'm right, and following the template, I know that it's a root b. So this has to be a, and this has to be b. So the answer for the numeric response question would be 8, 7. Okay, so let's talk about how we simplify with variables. We already know how to do perfect squares and perfect cubes with numbers. Let's look at variables. So variables can be perfect squares as well. Variables are in fact perfect squares when the exponents are a multiple of 2. So x squared would be a perfect square, x exponent 4, x exponent 6, etc. So those are all perfect squares with variables. Now to take the square root of a perfect square variable, you take half of the exponent. So for example, the square root of x squared is x because it's the second root, and 2 divided by 2 is 1. The square root of x exponent 4, square root has a root of 2. 4 divided by 2 is 2. The square root of x exponent 6, since it's a square root, 6 divided by 2 is 3. Now, why do we take half of the exponent? Well, that comes from switching from radical form to exponential form. Remember when we had a question like this, 2 to the 1/2, we knew that that was the same as the square root of 2, because square roots have exponents of 2. So using that idea, we can look at the example from an exponential perspective. So the square root of x exponent 6 is really x exponent 6 to the 1/2. And then following laws of exponents, you multiply 6 and a half together. So 6 times a half, or half of 6, is 3. So simply dividing it by 2. Whenever we're taking the square root of a number, we have to pay attention to the non-permissible values. Now, when I take the square root of a negative, in the real number system, that is not defined. So we know the square root of any negative number does not exist in the real number system. But do we know why that is? Let's look at the definition of a square root to help us. Square roots are one of two identical factors. So if the two factors are identical, they can't multiply to a negative. Let's look. If I had, for example, a negative times a negative, those are two identical factors, that's positive. Also, if I have positive times positive, well, that's also positive. So it would be impossible to multiply two numbers that are the same and get a negative value. Let's look at that with numbers. So 3 times 3 is 9, and negative 3 times negative 3 is also 9. There's no way I can multiply two identical numbers and get negative 9, for example. So anytime the index is even, you're taking an even root, square root, fourth root, sixth root. Always look for your non-permissible values if you have a variable under the radical symbol. Let's try an example. So write x exponent 4 times the square root of x as an entire radical. Entire radical means it's entirely under the radical symbol. Let's start with our non-permissible values first. You can't square root a negative number, so whatever this x is here, it has to be greater than or equal to 0. So to simplify this, since I'm taking the square root, to put x exponent 4 under the root symbol, I have to do the reverse of square root, which is squaring the number. So to square x exponent 4, laws of exponents, I multiply those together to get x exponent 8. Well, what do we do with the x exponent 8 and the x that's already under there? Well, we multiply them together. So multiplying them together, laws of exponent tell us to keep the base the same and add the exponents to get x exponent 9. So you guys know how I feel about checks? Big fan of the check. So you can see what I do here. Here's my original. Here's my answer. The check always happens in the table and I can see that they are equal, so I know I've done this question correctly. Let's try another one. So I want to simplify the square root of 72x exponent 4. So let's look for non-permissible values. So I have x exponent 4 and I'm taking the square root. So I said anytime you take the square root, the variable will be x is greater than or equal to 0. Now here's an exception. When the index and the exponent are both even numbers, there will be no restrictions. So the restriction comes from I don't want to take the square root of a negative. So let's imagine that x was negative and I'm raising it to the exponent of 4, which means multiplying it by itself 4 times. Well, here's an example. Negative 4 times negative 4, sorry, negative 2 times negative 2 times negative 2 times negative 2, 4 times positive 16. So even if it was a negative number, I would not be square rooting a number. So what I'm going to write is that x is an element of the reals, which tells someone that I know there might be a restriction, but in this case there isn't. X can be any real number. Okay, let's break this into perfect and non-perfect factors. So highest perfect square factor of 72 is 36. And 36 times 2 is 72. Perfect square factors for variables. Remember, I'm looking for even exponents. So since 4 is an even exponent, it is all perfect, nothing left over. So the square root of 36 is 6. And the square root of x exponent 4 is 4 divided by the root of 2, which is 2. And I'm going to multiply that by the root of 2. Now, you can leave the number or the answer looking like this, and that's okay. But the best way of writing it is number first, variable second. So I'm actually going to write this as 6 root 2 times x squared. So I put all my numbers together and then with the x squared. So like always, I want to check this on my calculator. So you can see here, I have the original, here I have the answer. Check always happens in the table, and I see that they are equal, so I know I've done this correctly. Let's try a simplifying question, where we're simplifying and then doing an operation of add or subtract. So because I have a variable under the root and it's an even root, I do have to state my restrictions. I can't square root a negative number, so c is greater than or equal to 0. Okay, let's break these down. So root 4c, I want to break it down into perfect and non-perfect factors, and the same thing for 2 root 9c. Notice I kept the 2 on the outside. Okay, so now I'm going to write it down in my perfect and non-perfect factors. So 4 itself is a perfect square, so that will go in my first one. I'm looking, since it's square root, for even powers, and c is to the exponent of 1, which is not an even number. 9 is a perfect factor, and again, c to the exponent of 1 is not a perfect factor. The first perfect factor would be c squared. Okay, so square root of 4 is 2 root c, minus 2 times the square root of 9 is 3 root c. So this is really 2 root c minus 6 root c. So they are like terms because the radical is identical, same index, same radicand. So if I have 2 root c's and I take away 6 root c's, I'm left with negative 4 root c's. Okay, so then I can check this on the calculator. I put my original question here into y1, my answer is in y2, and the check always happens in the table. You can see I did that correctly. Okay, let's talk about perfect cubes now. We already know about the numbers. Let's focus on the variables. So variables are perfect cubes if the exponents are multiples of 3. So for example, x cubed is a perfect cube. X exponent 3, x exponent 9, x exponent 12. So exponents are multiples of 3. Now the cube root is 1/3 of the exponent. So you take the exponent and divide it by 3. So look at the cube root of x cubed. 3 divided by 3, 1. The cube root of x exponent 6. 6 divided by 3 is 2. The cube root of x exponent 9. 9 divided by 3 is 3. So why am I taking 1/3 of the exponent when I'm doing the root? Why am I dividing by 3? Again, it comes back to switching between radical form and exponential form. So if I have, for example, 2 to the 1/3, that's the same as the cube root of 2. So we know from switching radical form to exponential form and vice versa, that's how I evaluate it. So here's an example. The cube root of x exponent 6. Well, to switch it into exponential form, the radicand stays the same as the base, x exponent 6 to the 1/3. And then laws of exponents tell me to multiply those together. So 6 times 1/3 is 2. So that's why we divide by 3. Let's talk about non-permissible values. Can you take the cube root of a negative number in the real number system? Well, let's look. Same logic for square roots. Cube roots are one of 3 identical factors. So if the 3 factors are identical, it can multiply to a positive or a negative. Let's look. I have negative times negative times negative. A negative and a negative is a positive, and another negative is negative. And then if I have a positive times a positive times a positive, well, 2 positives are positive, times by another positive, also positive. So you can see I can have a positive or a negative root. So let's look at that with numbers. So 3 identical factors. So 3 times 3 times 3 is 27. So the cube root of 27 is 3. But -3 times -3 times -3 is -27, which means the cube root of -27 is -3. So since I can cube root or fifth root or seventh root a negative number, there are no non-permissible values. But anytime there are variables, we do need to state that the variable is an element of the real, so that anybody that looks at that question knows there are no restrictions. Let's try this one. So I want to write this as an entire radical. It's a cube root with a variable. So first things first, state your restrictions. If the index is odd, there is no restriction. So I'll just write down x as an element of the reals. Okay, so I want to write this as an entire radical. So I want to put 2x cubed under the radical sign. So the 3 here tells me I'm taking the third root. So to put it under, I do the opposite, which is of cube rooting, which is cubing. So I cube 2x cubed. Now my tip here is don't forget about the 2. So 2 is cubed to get 8, and x cubed is also cubed. 3 times 3 is 9. So once I've done that, what do I do with the 8x exponent 9 and the 3x squared? Well, I multiply those together. So in my final answer, 8 times 3 and x exponent 9 times x squared, 24x exponent 11, the cube root of that. Again, always do a check. I have my original here. I have my answer here. Check in the table. I can see that they are equal, so I know I did that question correctly. Let's try another one here. So the cube root of 54x exponent 8. So again, because there is a variable, I have to look for restrictions. It is a cube root, so I know there are no restrictions. So I simply write x as an element of the reals. Okay, let's break this down into my perfect cube factors. There's my perfect cubes to help us. So I look at 54, and 54 has a perfect cube factor of 27. And it's 27 times 2. Okay, x exponent 8. I need a multiple of 3. So 3, 6, 9 is too much, so it's 6. So x exponent 6, and then I'm left with 2. I always like to do a quick check here. 27 times 2 is 54. X exponent 6 times x squared is x exponent 8. Now I'm good to go. So the cube root of 27 is 3. The cube root of x exponent 6 is 6 divided by 3 is 2, times by cube root of 2x squared. Anytime I have an index that is not a 2 in particular, I always put brackets around so you don't think that's x exponent 23. Okay, so let's put this in our calculator and do our little check. So in the calculator there, you can see my original question right here, my answer there. Check always happens in the table. I can see that they match, so I know I did that correctly. Okay, let's end with this last question here where we're simplifying and also subtracting. So again, I have variables under the root sign, so I always look for restrictions. Since it is a cube root, I know there are none, so I state that x is an element of the reals. Okay, let's break this down. So the cube root of 128, x exponent 4. I want to break that down into perfect and non-perfect factors. And the same thing over here. Okay, so looking at this, I'm going to break it down into my perfect cube factors, sorry, for numbers and variables. So 128 has a perfect cube factor of 64. And it's 64 times 2. I'm looking for perfect cubes, so my exponents have to be multiples of 3. So x cubed with 1 left over. Do a quick check. 64 times 2 is 128. X cubed times x is x exponent 4. Perfect. So to simplify this, the cube root of 64 is 4. The cube root of x cubed, 3 divided by 3 is 1. And I'll multiply that by the cube root of 2x. Okay. Next one. So my half comes outside, which is great. 16. Highest perfect cube factor of that is 8 with 2 left over. X cubed with 1 left over. Again, do a check. 8 times 2 is 16. X cubed times x is x exponent 4. So I have 1/2 of 2x. Cube root of 8 is 2. Cube root of x cubed, 3 divided by 3 is 1. times the cube root of 2x. So this is 4x cube root of 2x's minus half of 2 is 1, x cube root of 2x's. So notice they are like terms. They have the same index and the same radicand. So if I have 4x cube root of 2x's and I take away x cube root of 2x's, I'm left with 3x cube root of 2x's. So that just becomes like the variable, okay? And to combine the variable, I just add the numbers in front. So this one's a tough question. I would definitely check this one on the calculator. So you can see my original question here, my answer here, and check always happens in the table. I know I did that correctly. Okay, so to conclude this lesson, I want to leave you with a great math-inspired pickup line from none other than the Big Bang Theory. So here's what you do. You go up to the person that you want to impress and you say, you must be the square root of -1. Why, you might ask? Well, simply because you can't be real. Try it out, report back to me. Let me know if it was successful. You guys can move on to your practice questions in your notes and also in your textbooks. I hope this video helped, and I look forward to seeing you for the next one.